Okay, we just finished talking about segments, and we're going to keep talking about segments, but we're going to do a little bit more with them today. So we're still in section 1.2, but we're going to talk specifically about distance. Okay, distance is how far it is between two things. So first, we're going to talk about distance in one dimension. Okay, distance in one dimension. And what that means is if you think about a number line, right? You've done this before. Right? It doesn't matter how many marks you make, just try to make something similar to this. So this would be 0, 1, 2, 3, 4, 5. And then you know that this would be -1, -2, and so forth. Right? You've seen number lines like this before. So we're going to put some random points on here. Right? So -4 we'll have A, -2 we'll have B, and C will be at 1, and D will be at 3. Okay, this is one dimension. So if you were thinking about an X and Y axis, this would be like just the X direction, right? You don't need to put the X so much, but it's just the idea that this is the X direction or just one direction. All right, and we're going to write out a little sentence that may not be crystal clear yet, but we're going to write it out anyways because it's important that you can say the words and you can explain these things. So distance, this is in one dimension, is the absolute value of the difference between the coordinates. Of the difference between the coordinates. Now that may not make a whole lot of sense, but you know what all those words mean. So one thing that we learn in geometry is how to make sense of some of these words. So there's a lot of wording, a lot of writing in geometry. All right, so looking at this picture here, when it says distance is the absolute value of the difference between the coordinates. So the way you should think about that is that distance, d, right, we don't know what it is, so we're going to call it d for distance, is equal to the absolute value, remember that's a vertical line, of the coordinates. Now the coordinates are these points, so the coordinate for D is 3, the coordinate for C is 1. So our coordinates on our little x-axis are going to be an x2 and an x1, right? So the difference between those would be x2 minus x1. So it's important that we differentiate between our x's, right? We have, this could be an x, this could be an x. All these points are on the x-axis, so they're all x values. So let's say that we want to find out how far it is from C to D. Right? So I have CD with no bar on top of it. Well, I know that that's equal to the absolute value of x2 minus x1. So x2, this will be 1 and this will be 2, right? So x2 is 3, x1 is 1. So 3 minus 1 equals the absolute value of 2, which is 2. So CD equals 2. Now, sometimes people get mixed up with which one's 1 and which one's 2. And the good thing is it doesn't matter. So I'm going to redo this problem, but I'm going to mix them up and make this 2 and this 1. So we have the absolute value of x2 minus x1. So x2, so C is 1, minus x1, so D is 3, and that equals the absolute value of -2. But hopefully you remember absolute value means that we want the positive value always. So the absolute value of -2 is still 2. So we still get CD is equal to 2. So don't stress too much about which one is the right one. Just pick one, make that one 2, and make the other one 1, and go with it. You won't have any problems. So that's how we do distance in one dimension. If we did one more example, if we wanted to do AC, okay, the distance from A to C is x2 minus x1, and x2 will be C, so I'll do 1 minus, and then A is -4, so 1 minus -4. Well, that's equal to the absolute value of 1 plus 4, which is equal to the absolute value of 5, which is just 5. So AC equals 5. And that's how you find distance in one dimension. Very easy, very basic. You could count the spaces if you want instead. But either way, that's how it works. Now we're going to move on to distance in 2 dimensions. So let's write that down. Distance in 2 dimensions. Now this one's going to be a little trickier, but it's still not bad. So I'm going to draw a graph real quick, and you need to do the same thing. So we're going to make a little XY graph. This is something that we need to get good at, drawing these. Again, don't get caught up in how many dashes I'm making, and just make a graph. Okay, so there's my graph. I'll even erase the little edges I made too long. Alright. So we have a graph, and we're going to put some points on this graph. So the first point I'm going to put is going to be -4, -6. So 1, 2, 3, 4, then 1, 2, 3, 4, 5, 6. So just roughly getting it in the right spot, right? So this is going to be point C. And point C is -4, -6. And then I'm going to have point D at 5, 1. So 1, 2, 3, 4, 5, 1. So this is point D, 5, 1. And what we need to figure out is the distance between C and D. So effectively, we're figuring out how long is line segment CD. So we're going to figure out how long is CD, right? But to do it, we're going to use a formula that you probably haven't done before. It's called the distance formula. And before we do that, we're going to write down in words, just like we did for our line segment, for our 1 dimension. We're going to write down the words for 2 dimensions. So distance is the square root of the sum of the squares of the difference between the coordinates. Okay, now I'm sure that doesn't sound very pleasant, but if you can make sense of these words as we learn this, and I don't mean right this minute, I mean by the time you take the test, or by the time you go to Algebra 2, or by the time you go become an engineer, or whatever you want to be, being able to articulate what's happening is almost as important as being able to do it, because if you can't explain something to other people, you can't articulate it, then you're really not very useful, because you're the only one that can do anything and you can't help anybody else, right? So we're going to write down our formula now. So this is the distance formula. And this is an important one, so we're going to want to put a box around this, highlight it, whatever you do. This has got to be committed to memory. All right, so the distance formula says that the distance is the square root right? So long square root of the sum of the squares of the difference between the coordinates. So our coordinates here are these -4, -6, and 5, and 1. So this is going to be x1, y1, because this is x and y of point C. This is going to be x2 and y2, the x and y of point D. I can't call them x and x, right, because there's two of them. So I have to differentiate now. So the difference between the coordinates, so x2 minus x1, sum of the squares of the difference. So I'm squaring the difference, and then I'm adding it to the difference squared of the y-coordinates. And this is the distance formula. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You will memorize it very quickly, very easily. It's not hard. It's always the same. And the great thing about it is it always works. So here is our distance formula. So we're going to find out how long is segment CD. Well, we're using our distance formula. Remember, x2 minus x1 squared plus y2 minus y1 squared. That's our distance formula. So we're just going to substitute everything into that. So x2 is 5 minus -4 squared plus y2 is 1 minus -6 squared. So then we just start to simplify all this, right? 5 minus -4 is 5 plus 4, so that's 9 squared, plus 1 minus -6 is 7, so that's 7 squared. And we just keep going, keep simplifying. So 81 plus 49. 81 plus 49 is 130, all still square rooted. Now, eventually we're going to simplify these radicals and have exact perfect answers, and everything's going to be really neat and pretty. But today, let's just type square root of 130 into the calculator, and we get 11.4. So CD is approximately 11.4 units long. Now, if you don't believe that, or you need to check it, you can go back up to the graph, back up to our picture, and we can add some little lines like this, little line segments. Notice I'm making them dotted because they aren't part of my picture. I'm adding these extra. These are called little auxiliary lines that I'm adding to my picture. Now, if we look at how tall this side of this right triangle would be, to go from here down to here takes up 1, 2, 3, 4, 5, 6, 7. 7 spaces. And to go from -4 over to here to 5, so -4 to 5 takes up 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. Right? So we have this triangle, we have this right triangle that looks like this. This is 7, and this is 9. And remember, we were looking for this, because this is our CD. So another way to do that is to use the Pythagorean theorem. A squared plus b squared equals c squared. So we would do 7 squared plus 9 squared equals x squared. But before I keep going with that, do you notice 7 squared, 7 squared, 9 squared, 9 squared? So we're doing the same exact thing. The Pythagorean theorem and the distance formula are the exact same formula. One just uses the numbers from the points, so the actual coordinates, and the other one uses the length of the actual segment. So this is 49 plus 81 equals x squared, 130 equals x squared, and then you know to solve this we have to square root it. So the square root of 130, 11.4, is approximately equal to x. Now you might say, why in the world would I want to do this stupid formula when I can just do the Pythagorean theorem? Well, that's a good question, because in this picture you probably easily could have done the Pythagorean theorem. But imagine that you were just given 2 points and they said, so let's mark this out. This isn't really part of this problem, but say you got a point and they said point A is negative 21 comma 17 and point B is 31.2 comma negative 33, and it says find AB. Well, you don't have a graph, right? And if you do have one, it's not going to have 33 spaces on it, so you can't graph this, you can't draw this. All you can do is figure out where this 7 and where this 9 come from, and the easiest way to do it is right here, x2 minus x1, y2 minus y1. You take these numbers, x2 or x1, y1, x2, y2, and you just plug them into the distance formula and it spits out the right answer. So that's how you find distance in 1 dimension and 2 dimensions, and one day we'll do 3 dimensions and you'll see it's very similar to this as well. So have a great day.